Hello and Assalamualaikum. We are a student from Power Quality Subject, Section 2, Group 14. Our lecturer is Professor Madia IR Dr. Rahman bin Hanafi. So the purpose of this video is to do a presentation for our Power Quality assignment, which the title is Generation of Different Power Quality Disturbance and Their Respective Mitigation. So this group stands of 4 members, which is Amirul bin Zuhaili, me as the group leader. Second is Ainur Maisarah binti Ahmad faris. The third one is Mohamad Afiq Afandi bin Mohamad Khusrin, and the last one is the Umarull Hashimi bin Abdul Ghafar. So without further ado, let's jump to the first slide. So I will start with the introduction. So the important thing is that we need to understand about the power quality first, right? So power quality is one of the important things that need to be concerned as to make a good electrical or electronic systems. So there are so many definitions of power quality according to a different perspective, right? So the one that I want to highlight, which is the easy way, the simple way, is by according to the load aspect. Alright, so it defines the power quality as the power supply for satisfactory performance of all the equipments. And what about the power quality disturbance? Alright, so it is a term used to define a problem manifested in voltage and the current wave shift on the power system without resulting in a loss of power supply. Nowadays, the typical types of power quality issues are detected to be more than one, and these kind of issues make the supply received by the consumer or the loads have many losses. So as we can see here, the table shows the power quality disturbance occurred in most of the time. So there are 4 disturbances in total we're going to be discussed, which are: the first one is voltage side, the voltage swell, the transient, and also the harmonics. So we're going to look one by one. So for voltage side, it is occur when the RMS voltage magnitude decrease between 0.1 to 0.9, and it lasts for 0.5 cycles to 7 seconds. Right, so the causes is because of the switching of heavy loads and also the remote system faults. So the effect is the dimming of lighting system. So the solution to overcome voltage side is by using the very resonant transformer and also the uninterruptible power supply, or known as UPS. So the second one is the voltage swell. So voltage swell is increase in voltage magnitude between 1.1 to 1.8 pu. Okay, so it most common duration is between 0.5 to 1 minute, and it only appears in a momentary before it back to the initial conditions. Okay, so the causes is because of the unreliable grid system and also the remote system fault. So the effects is the equipment does not work properly, and the solution is the same with the voltage side, which is the very resonant transformer and also the uninterruptible power supply. So next is the transient. So transient, in some cases, it is known as the voltage spike. Okay, it is high over voltage disturbance that lasts only a few seconds. Okay, so if you want to make the differences between the transient and also the voltage swell, is we have to look at the waveform, right? So for transient, it is large in magnitude and short in duration. We can see a spike occur at the waveform, right? So transient is commonly happen during the phenomenon of lightning strike, and sometimes sometimes in lightning, okay, and sometimes in switching. Okay, so the effect is it will attack the system, right? So that's why we're going to have a system failure, right? So for the solution, we have to apply the filters and also do the isolation transformer, use the isolation transformer. Okay, so the last one is the harmonics. So harmonics, it is known as the type of voltage or the current waveform distortion, which we so these 2 tasks are going to be simulated and going to be presented by my friends. Alright, so that's only for my parts. Now I will pass to Umarull Hashimi for task 1.
Hello, Assalamualaikum. My name is Umarull Hashimi bin Abdul Ghafar, and my metric number is DA190196. Okay, I will present to you the simulation of mitigating PQ problem caused by our voltage transients. Okay, so what we have to do is we have to do the circuit of the surge arrestor in transmission line, and then run using any software. So we are using the MATLAB software. So this is the finished circuit with as in the instruction the circuit same. So the first situation or first condition is where is the load breaker is closed and the fault is open. So just run. Okay, we have to see the result at the series compensated and the shunt compensated for both voltage and current. Okay, at the series compensated, as we can see here the measurement of the voltage and current. Next, at the shunt compensated, voltage and current also. Okay, for the second condition is where both fault and load breaker is in the closed condition. So I have to run again. Okay, we can see the series compensated. As you can see, there is a change in measurement for both current and voltage at the series compensated. Same goes to the shunt compensated. There is some transient or disturbance here after 0.1 second. And for the final condition, which is the load breaker is not connected, or we can say it is in the open. So as we can see, only after 0.1 second there's some reading of the voltage. Next, at the shunt compensated, we get a stable voltage reading and there is no current measurement. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Afandi bin Mohamad Khusrin. My metric number is DE110109. In this video, I will explain about the task 2, which is the simulation of harmonic producing load and mitigating filter. Okay, this is the three-phase harmonic filter equivalent circuit where it uses 500 kV of DC and the firing angle is 19 degree. So after we run the simulation, we can get the reading of the voltage and the ampere, which is 500 kV and 2 kiloampere. Next, in this equivalent circuit, there are also three types of filter that connect with the breaker in this circuit, which is C-type filter, use 150 megabar. The next one is tune filter, also use 150 megabar. And the last one is high pass filter, also use 150 megabar. This filter will help to reduce the distortion in the equivalent circuit. After we run the equivalent circuit, we can check the output waveform from the circuit by clicking the scope here. So after we click the scope, it shows the output waveform of the voltage for B1, current for B1, and current for B2. So for the voltage B1, it shows the perfect sinusoidal waveform. So the highest peak of the form is 0.4 megabar. Next, for the current for B1, the first two waveform show the ripple here, but after that, it become the perfect sinusoidal waveform. So the highest peak for the first two waveform here is 2 kiloampere, and the rest of the waveform has the 1.8 kiloampere. The next one is current for B2. So the current B2 show the ripple waveform from starting to the end of the waveform. So the highest peak of the current for B2 is 2.0 kiloampere. Next, we simulate the equivalent circuit by open the breaker 1 here. when the breaker 1 is open, the condition of filters here will turn into the deactivate condition. So we can find out the output waveform from the scope 1 here. So after we click the scope 1, it shows the waveform for the VAVC V1, IAVC V1, and IAVC V2. The waveform show the highest distortion occur at the VAVC V1. This is because the filter cannot filter the ripple or the distortion occur in the equivalent circuit here. Next, I will show the fast Fourier transform analysis, FFT analysis, with the filter disconnected. So the graph show the result from the voltage and the current when the filter is disconnected. So from the bar graph here, it shows the THD in the voltage is 13.86%. This value show that it high and unacceptable in THD system. Same goes to the current. So the total harmonic distortion percentage in this current is 23.15%. So it seems like the voltage value here, it's very high and unacceptable in THD system. After the filter connect in the equivalent circuit, it shows the waveform for the voltage and the current become stable, and it shows the perfect sinusoidal waveform for current and the voltage here. So the total harmonic distortion at this stage is 11.52. It decreased from 13.8% before it connect with the filter. So the total harmonic distortion for the current when the filter is connected is 32.79%. The last part in this simulation is impedance versus frequency graph. So this shows the impedance versus frequency graph that obtained from the impedance versus frequency block here. So from the graph here, the plotted X here shows the value of impedance, which is 417 ohm at frequency 60 Hz. So from this value, the value of reactive power can be obtained by using the formula, which is V squared over the value of impedance, which is 417. So the calculation value at the final is approximately reached at 600 megavar. That's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ainur Maisarah binti Ahmad Faris, and my metric number is TE190187. So for my part, I will be presenting for the conclusion. So from the above experiment and the result, it can be concluded that the typical causes of voltage sag and swell is the system remote fault. It is said that the voltage sags and swells are the most prevalent types of power quality disturbances. Overvoltage transients are caused by the lightning and the load switching. The cause of the harmonics are nonlinear load and system resonance. The solution that can solve each of the power quality disturbances are also well explained in this report. This research and assignment covered various types of power quality phenomena in one graph and their respective measurement. Then, students able to present and understand the application of power quality issue. Lastly, all the objectives in this assignment have been achieved by completing the report comprehensively in identify and mitigate the power quality phenomena. That is all from me and my group. Thank you.